Okay, we are on unit 0 and we are doing day 3, solving a 3-variable linear system. And we're going to go through these steps up top as we go through our system. And here is our first goal. We're going to take the system of 3 equations and turn it into a 2-equation system. We can't do that unless we eliminate a variable. And we're going to do 2 steps where it eliminates a variable, thus turning it into a system of 2 equations with 2 variables. So the first thing we have to look for is that these systems, that these equations are all lining up. So all the x terms line up here, all the y terms line up here, all the z terms line up here, all the equal signs line up here, and all the numbers line up here. So this system is in good shape. And now what we do is we scan through and we ask ourselves which variable is the easiest to eliminate. So what you're looking for is that the coefficients out in front are the same. And if we look at the x's, we have a 2, a 6, and a -4. None of those are the same. So it's probably not going to be the easiest to eliminate. The next one, we have a 1y, a 3, and a 4. Also not the same. But if you take a look at those z's right here, all of them have a coefficient of 1. And even better yet, some are positive ones or some are negative ones. And that's exactly what we want. So we're going to go ahead and set up our first goal. And we're going to eliminate z. We're not going to do it once. We're going to also do it a second time, okay? And so I'm going to number these equations so we can talk about them easier, okay? But equation number 1 and number 2 already have z's where they're opposites. And so all we have to do is take equation 1 and recopy it. And you'll notice I put a line through my z so they don't look like 2's. And I'm going to take equation 2 and I'm going to put it right underneath equation 1. Because they're opposites, all we have to do is add these 2 equations together. 2x plus 6x is 8x. Positive y minus 3y is negative 2y. And this is what we're looking for. Positive z plus a negative z, they're opposites of each other. They're going to cancel each other out. And 15 plus 35 is 50. Now we're going to go ahead and set up our second. Now we're going to go ahead and set up our second 2 equations where we're going to eliminate z. So that's the important part. You got to do it again. So because we already did 1 and 2, you can either do equation 1 and 3, or we can do equation 2 and 3. Based on looking at the equations, it's going to be easier to do 1 and 3 because the z's are opposites in those. In 2 and 3, they're both negative, and so we'd have to multiply through by a -1, and that's more work. So we're going to go ahead and stick with equation 1. And so I'm going to write it over here, 2x plus y plus z equals 15. And then we're going to take equation 3, which is negative 4x plus 4y minus z equals negative 14. Again, when the variables are opposites, we're going to add the 2 equations and they will eliminate. So we have a 2x plus a negative 4x, or 2x minus 4x, same thing, is negative 2x. Positive y plus 4y is plus 5y. And the z's are opposites. They will eliminate. And we're going to have an equals, and 15 minus 14 is 1. Okay. If you look, now we have 2 equations with both x and y in it. And so now it turns into what we were doing on day 2. So now we have to set up our second goal. Do we want to eliminate x or do we want to eliminate y? It is easier to eliminate x. Why? Because all we have to do is take this equation right here and multiply by a 4. That's going to turn it into a negative 8x. And if you look over here, we have a positive 8x, and they'll eliminate. So we're going to copy down this first equation here which is 8x minus 2y equals 50. That's just for that equation right there. Okay. This other equation, we're going to multiply through by a 4, and that's going to turn this into a negative 8x. And then we're going to get a positive 20y. And then equals 4 times 1, which is 4. We're going to go ahead and add the two equations together again. And there go the x's because they're opposites. What we have left is negative 2y plus 20y, which is 18y, equal to a 50 plus a 4, which is a 54. We have one last step, and we're going to have one of our variables solved. If we divide by 18, y will come out to be 3. And we'll box them up. All right, just because we have y doesn't mean we're done. We still have to get x and z. So where we're allowed to go now is back to either this equation or this equation, because both of them have the y and x. We can't go back to the originals with only one variable. When we have 3 variables, we won't be able to solve for the other 2. So you pick whichever equation you like better. I'm going to go ahead and do this one. And so I'm going to say negative 2x plus 5, but the y comes out and 3 goes in because we just solved for y and found out that it's 3. And we're just going to simplify. So this is going to turn into a plus 15. We're going to go ahead and subtract 15. We end up with negative 2x is equal to a negative 14. And we're going to go ahead and divide by negative 2. And x is going to come out to equal 7. And now we have 2 out of our 3 variables. Now what we're going to do is we're going to go back to these original 3 equations. And it's up to you, whichever one you want to pick. I'm going to pick the first one. And so we'll go ahead and do 2. But x comes out, 7 goes in since we just solved for x. We're going to add y, which is 3. We're going to add z, which we don't know yet, equal to 15. This comes out to be 14 plus 3 plus z equals 15. That's 17 plus z equals 15. Subtract 17. And z comes out to equal negative 2. And now we have all 3 variables. If you wanted to check, you take the other 2 remaining equations, you plug all 3 variables in, and you see if the left side of the equation comes out to equal the right side. And if it works for all 3 equations, then these are our 3 answers. Okay, we're going to try another one. Down here at the bottom, number 2. Again, your first job is to make sure things line up. All the x's line up, all the y's line up, all the z's line up, all the equal signs line up, and all the numbers line up. Okay, now we're going to go ahead and scope out which variable is the easiest one to eliminate. If you look at the x's, we have 4, negative 2, and 5. They're all different. The y's, well, 2 of them are the same. We have a coefficient of 1 on the y's on 2 of the equations and a 4 on the other. So far, y is looking good. Z's all different. You got a 3, a 2, and a 7. So we're going to go ahead and set up our goal. And our goal is to eliminate y this time. Remember, you have to do it twice. So I'm going to number the equations. And the easiest ones is to do 1 and 3, since if you look at their y's, they're opposites already. So I'm going to go ahead and write down the first equation, which is 4x plus y minus 3z equals negative 6. Second equation, which is the third one actually, is 5x minus y minus 7z equals negative 19. Again, we add the 2 equations together. And so this ends up being 9x. The y's are opposite, and so they will cancel each other out. Negative 3z minus 7z is negative 10z equal to a negative 25. All right, we have to do the same thing, but with either 1 and 2 or 2 and 3. I'm going to go ahead and say it might be easiest to do 2 and 3. However, equation number 2 is going to, nope, not equation 2. Let's go back and erase that. Not equation 2. Equation 2 is fine. We are going to take equation 3 and multiply through by 4. Because when we do, that's going to turn the negative y into a negative 4y, and then it'll be opposite of what we have in 2. So we're going to take equation 2. It's fine just the way it is. So negative 2x plus 4y plus 2z equals 38. The third equation, when I multiply through by a 4, we'll change it into a 20x minus 4y minus 28z equal to 4 times negative 19 is negative 76. We're going to go ahead and add the two equations together again. Negative 2x plus 20x is 18x. The y terms are opposites of each other and will cancel. 2 minus 28 is negative 26z equal to a 38 minus a 76, which is negative 38. And now we have two equations with the same two variables in it. And so now we are ready to set up our second goal. And we have to scope out which variable, x or z, is the easiest to eliminate. Taking a look, it's going to be the easiest to eliminate x. All this equation needs to be done with is to multiply through by a negative 2, turning into a negative 18x to match that positive 18x. So this first equation will become negative 18x plus 20z equal to positive 50. The second equation is good to go. And again, we're going to add them together. And we're going to eliminate x this time because these are opposites, leaving us with a 20z minus 26z, which is negative 6z, equal to a 50 minus 38, which is 12. Divide by negative 6, and z comes out to equal negative 2. That's a negative. Okay, box that up. And we have one variable down. Remember where we go back to. We can either go back to this equation that has x and z in it, or we can go back to this equation that has x and z in it. Does not matter. You pick which one's easier. I'm going to pick the first one. So we're going to keep the 9x minus 10. Z comes out. Negative 2 goes in, equal to a negative 25. This becomes 9x plus 20 equals a negative 25. Subtract 20. We get 9x is equal to a negative 45. We're going to divide by 9, and x comes out to equal negative 5. Box that up, and now that we have two variables, we can go back to one of the original three equations. It does not matter which one you use. I'm going to use the first one. And so that's going to say 4. X comes out, negative 5 goes in, plus y, which we don't have, minus 3 times z, which is negative 2, equal to our negative 6. This becomes negative 20 plus y plus 6 equals negative 6. You got a negative 20 here and a plus 6 there, which is negative 14. I'm going to go ahead and add 14. And y comes out to equal 8. And now we have all three variables. If you wanted to check it, you could. You'd plug all three variables into all three equations, making sure that the left side equals the right side. And that is how you solve a system of three equations.